All right, so you should have the blue worksheet in front of you. We want to be on the side to start out that says use the velocity graph to determine how far they have traveled. When you're working on this, you're welcome to use your calculator. You may want it for some of the parts. Based on what we've seen in class, if we want to know somebody's position from their velocity graph, we want to find the area under the velocity graph. If the question said to find the position graph, we would do a t-table for our time and our position and do our areas at each individual second. But this question does not say we need to do the position graph. We just need to know how far they have traveled overall. So therefore, we just need to know the area under the velocity graph at the very end. So our task here, to find how far they traveled, is just what's the area under this graph from 0 to 9 seconds, it looks like there. Well, to do this, we can just split into convenient shapes. So let's see if we can break off the triangles first. So here's a triangle, and here's a triangle. And then we can split this into two rectangles. So I'm going to call this area 1, area 2, area 3, and area 4. Now what we need to start getting away from is just counting boxes. Because what you'll notice on this sheet is the scales will sometimes change. So we want to think dimensions of our shape based on the scales. So for area 1, we've got a rectangle. Based on our scale, we have a base of 6, and we've got a height of 3. And that's not because it's 6 blocks and 3 blocks. It's because based on our scale, it's 6 and 3. Again, if you look further in the on the page, the scales are not going by 1 each time. So you got to be careful and think about what is the base and height based on the scales. So for this area, we just have 3 times 6, so we get 18. For section 2, we have a triangle. The base of our triangle is 4. The height of our triangle is 2. And then base times height divided by 2 for a triangle. The height should be the straight up and down height. 4 times 2 is 8, divided by 2 is 4. Area 3 is a little triangle. Our area for that one, we have a base of 1, a height of 1, and then base times height divided by 2, so we'll get a half. Or I guess that comes out nice, so I'll just put it as 0.5. If it didn't come out nice, we'd leave it as a fraction. And then lastly, we've got a rectangle. The base is 3, the height is 2, so we get 6. And then we're just going to add those all up. So 18 plus 4 plus 0.5 plus 6. And if we add those up, we get 28.5. The units we've been seeing, even though it doesn't specifically say the units on here, the units we've been seeing for most of these for our position has been meters. Now I'm going to say this again, and people will still make the mistake. Be careful of the scales on the next two. One box does not count as 1. You've got to see what the scale is to determine the dimensions of your figure. So that's what you'll do on this side of the blue sheet. If you could flip over to the other side of the blue sheet, we now want to sketch the velocity graph. And what they've given us is a position graph. The reason we know that is based off of the units. On our y-axis, we just have meters, which is a position. So for our velocity graph, let's start by drawing ourselves an axis. Let's put units on those axes. We've got seconds, and then the velocity would be meters per second, because they told us meters. And when we first started this unit, we did the motion detectors. And we saw that when we went faster, the steeper our lines got. When we went slower, they were less steep. So your velocity, or how fast you're going, is connected to the slope. So the slope is what should be telling us our velocities. So let's go ahead, we'll put a scale in. Looks like our graph goes out to 7 seconds. We'll start out with that on the velocity axis. We'll see if we need to go higher. So we've got a line to start out. We want to find its slope. Well, slope is change in y over change in x. So let's see how much it goes up first. So it goes up 6, and it goes over 2. So we'll do 6 divided by 2, and that tells us that the slope of this line is 3. So we've got to think about during what times is the slope 3. Well, it started out at 0 seconds and went to 2 seconds. So on our velocity graph, we'll have a horizontal line at 3 from 0 to 2 seconds. Our next section, let's find the slope. We go up 1 and over 2. So 1 divided by 2, that just gives us a half. So this section has a slope of a half. That lasts from 2 seconds to 4 seconds. So from 2 seconds to 4 seconds, we'll draw our velocity in at a half. Now, anytime you've drawn in a velocity and it is not at an integer value, you need to label on your y-axis what that value is. Because if you just draw it in, we don't know, is it a half, is it 3/5, is it 2/3? So you need to label it on your y-axis when it is not a integer. Our next section is just a horizontal line. We went up 0 and over 2. 0 over 2 is just 0. So from 4 seconds to 6 seconds, we should be at 0. Now, most of you will probably just be using your regular pencil, so just make it a little thicker on the x-axis there so it's clear that's where we are. And then our last section, we're going up 1, 2, 3, and over 2. So 3 over 2 is really 1.5, or you can leave it as 3 halves. And that was lasting from 6 to 8 seconds. So it looks like I got to go one more on my scale. So from 6 to 8 seconds, we'll be at 1.5. Again, that's not a nice value, so we've got to label either 3 halves or 1.5 on our axis. We want things to be exact. If that was, say, like 2/3, we wouldn't want to put 0.6 or 0.6 repeating. Actually leave it as 2/3. So you've got 2 more that you're going to do on each side. After each of them, get up and check your answer after each individual one to make sure you are on the right track. Be careful when you're checking your answer to make sure you have labels and everything matching with the key. Have a good rest of your day.